Okay, we're in video number 2 of intuition and intelligent T-charts. I know it's a weighty subject. Your brain will become more and more used to it the more you practice it, but in the beginning, it probably is rough on the brain. So, in the previous video, most of the problems we ended up approaching infinity, but for these examples, most of the time we're not going to be approaching infinity. So in this example, I'm approaching 5 from the right. Now, so it's a right-hand limit. You know that I could try to plug in a 5, but the denominator would then equal 0. Big explosion. So what I'm going to do is I'm going to do this intelligent T-chart idea, or intuition, because pretend I don't know what the graph of that looks like. Some of you might. There doesn't seem to be algebra trickery to work, and there's no memory limit here. So kind of what we did before, I'm going to unveil this T-chart. And what I get is my x values, I mimic closing in on 5 from the right. So I start at positive, I really could start at 73 million, then 100, then 90, 80, 70, 60. The point is I don't really care until I'm closing in on 5 coming in from the right. So as I do that, I imagine taking each one of these and plugging it into that fraction. And as I do that, the numerator always stays 7. But as these x values get closer to 5, my denominator's calculation becomes very tiny. Imagine plugging a 5.001 into the denominator. I get a positive answer, but it's tiny. So my trend is 7 over tinier and tinier. If I were to put that into just made up fractions, it would look like this. So if you were to compute the values of each of those fractions, you would notice that they're getting larger and larger. So I get an infinity there. To be really precise, I get a positive infinity, and that could matter. I know that if you don't put the positive sign there, we just assume it's infinite positive, so that's fine. The second problem looks almost identical, but now I notice that we have a left-hand limit. Same thing as before, the plug-in gives you big explosion, no algebra trickery, not a memory limit, all that good stuff. So I unveil this T-chart. I'm sneaking up on 5 from the left, which means I start in the land of negatives. I get closer and closer to 5. I never get to 5 because I don't care what happens at 5, just the trend as I'm getting there close. So now as I plug in these values that I'm really caring about, my denominator is negative but super, super tiny. So I have this trend of 7 divided by a negative number that's tinier. So it might be like this. And you get the point. We're going to end up going to negative infinity. I've looked at the right-hand limit, I've looked at the left-hand limit, and using intelligent T-charts, but just so you know, the same question could have been given to you this way. We could have said, hey, what's the limit as x approaches 5? And you would look at that and you'd say, well, what am I supposed to do for my T-chart? Should I approach from the left or the right? It doesn't tell me. Remember, the fundamental of limits is to find out if a limit exists, you must look at the left-hand limit and compare it to the right-hand limit. So if you were given this, your brain would have to go through this process. And in this case, the right-hand limit and the left-hand limit give you different answers. So this would either be that, or you could call it does not exist. So that's just a little side note. All right, let's do another one like this, but it's going to get a little bit freaky. Okay, you can probably see why this one's going to get a little bit freaky. We're using a trig function, and we're using secant. That's not fair. You can't use secant. It's not one of the famous ones. Well, if you don't like working with secant, and there's a good chance you don't, why not just rewrite this in the form of something you do feel comfortable with, which is cosine. Secant is 1 over cosine, so let's go with that. Now, also, they're just asking for as x approaches pi over 2, so we have to do the left and the right hand limit. So I'm going to start with the left hand limit. Let me pause while I wrote this stuff. Okay, so you see I've written a bunch of stuff on paper because what I'm about to show you is kind of a mind trap, a Bermuda Triangle of calculus and trigonometry. We decided that we're better off doing this fraction, and since it says approaching pi over 2, it doesn't say from the left or the right, we're obligated to consider the left and the right. So let's think about the left-hand limit. I'm approaching pi over 2 from the left, and to the left of pi over 2 is 0. And then if I think about sneaking up on it, I'd go to pi over 6, pi over 4, and eventually get to pi over 2. So in the drawings that I have below, we're going to have the left-hand limit be in green. If you think about trigonometry like a regular old number line, as I approach pi over 2 from the left, I'm coming in from this direction, which is how I'm getting these values on here. But be careful, because you like to think of trigonometry in the unit circle, and from the negative side on the unit circle, you approach from over here, because here's 0, pi over 6, pi over 4, pi over 3, pi over 2. So it's counterintuitive. Approaching from the left on the unit circle, you're physically on the right side. So notice this makes sense on the number line. It bends your brain on the unit circle. The right-hand limit, approaching from the right, that makes sense on the number line, but on the unit circle, all of these values are hanging out over here. Here is pi, here's 3 pi over 4, and so on. So be very careful of this little trap. It gets very rough. So in this case, as I approach from the left, which is over here, or better yet over here on the unit circle, my cosine values are positive and getting tinier. Now how do I know that? As I'm going down this part of the unit circle, all of those spots, my cosine, which is my left and right component, is positive, because each one of these is to the right of the origin, but they're getting smaller and smaller and smaller. When I'm here, my cosine is pretty far to the right. When I'm here, it's just barely to the right. So I end up, this trend gives me positive infinity. Let's approach pi over 2 from the positive side. On the number line, it looks like this. On the unit circle, it looks like this. All of these cosine values, as I get closer and closer, are negative. But those negative cosine values are getting smaller and smaller. So this trend would give us negative infinity, because 1 over something negative tiny and tinier would look like this. And we would just keep that going. So the bottom line is my left-hand limit and my right-hand limit are not equal. So my final answer to this original problem, way up here in the beginning, is one of these, or does not exist. So the purpose of this one was to get you more used to the intelligent t-charts, but to show you this little mind-melting phenomenon. We've got one more example. Actually, before we go to that example, I just want to show you graphically what we just did. We said, hey, we don't know what secant looks like. Let's turn this into 1 over cosine and evaluate the left and the right hand limits. So I put the 1 over cosine into my calculator, which is really like the secant function, and I graphed it. And this is the spot pi over 2. Notice as I approach pi over 2 from the left, my graph is heading off to infinity. As I approach pi over 2 from the right, my graph is heading off to negative infinity. Thus, at pi over 2, the limit does not exist. Okay, final example of your intelligent T-chart style thinking or intuition style thinking. I want to do this limit, and I always want to try plugging in a 0. Cosine of 0, no big deal, that is 1. Natural log of 0, that's a big deal because that's an explosion in the denominator. I've graphed the natural log of x for us, and as you know, as we approach 0, natural log of x never gets there. It has this vertical asymptote. Another very important spot on natural log, not important in this specific example, the x-intercept. Well, since that's not working, the plugin isn't working, and I don't see algebra trickery or memory limit, or I don't necessarily know what the graph of that whole monster looks like, I can go to Intelligent T-chart, and as I approach 0, I need to think about, wait, they didn't tell us left or right hand limit, so that means we'd have to think of both the left and the right hand limit. Lucky for us, natural log of x only exists to the right side of 0. Even though cosine exists on both sides, natural log only exists on this side, so I really only have to think of the right side or the right hand limit. So I'm going to think in my head, all right, I'm going to go like 10, 5, 3, 2, 1. You get the point. Now what's happening as I close in on a 0, it's kind of tough, but as I close in on a 0, this is really the only area I care about. Cosine of 0 is closing in on 1. I'll say 1-ish, because it never really gets to 1, because we never really get to 0. And by the way, it's a positive 1, because if you think of the unit circle, as I'm closing in on 0 from the right, remember the unit circle is tricky, my cosine values are all positive as I approach that spot. Now let's think of the natural log. As I'm approaching 0, the natural log is getting negative and huge. So that says huger, bad writing. So 1 divided by something that negative, huger, and huger, the trend would look like this. So I don't care that these are negative because 1 divided by huger and huger numbers is approaching 0. 0 doesn't have positives or negatives. All right. You are now saturated in the brain with limit knowledge. The only thing you don't know about with limits right now is L'Hopital's rule, and Johnny L'Hopital is very dangerous, so we're not going to learn about that until later in the year. See you later.